So thus far we've been talking mostly about harvesting machinery, but a big part of planning a harvest as well is planning out roads, because that equipment needs to get in and the logs need to get to the mill. So could you talk just very generally, if you're planning a cut block and maybe there's some road access but not sufficient roads, what are the things that you're thinking about when you're thinking about designing roads or putting roads in to access a cut block?
The road building here on the coast is very different from the interior. So we're in a coastal situation here, and road development is a very big cost here compared to the interior, mainly because we're on either steep slopes or organics or a combination of everything. And so we choose to build our roads out of quarried material on site, and that involves us finding rock either in the road where the road is going to go or nearby in a pocket that we can then develop and blast. And our drilling pattern and our blast pattern is going to help us yield the size of rock that we need to build from.
So you find bedrock that's at a location convenient to where you're trying to build your roads, that you don't have to have a lot of costs of moving it, and then when you use explosives to blow that up into small pieces, you do that in a way to try to yield the types of rock that you need for the road.
The volume we need for the road building, and then the size of rock that we would like to work with. Road building here on the coast is anywhere from $120 to about $180 per meter, a length of road. And so our roads can vary in width in some places, in turns and landings and things like this. But generally our right-of-way and our clearing path that we're doing through the forest is 15 meters wide. So that's that cost, 1 meter by 15 meters.
And roughly how deep is the road bed that you make? I suppose it depends a bit on soil and also if the terrain is very smooth versus undulating, you have to smooth it out.
Yeah, it depends a lot on what you are building on. There's some places where we put it on really thin, and some places where we have to really build it up. If you're coming up a hill like this with a loaded truck, and you had a dip and then a climb, it's actually harder for that truck. If that truck can maintain momentum and keep a steady grade going up a hill, then we'll take the time to fill in and make a constant grade for them within reason. Knowing the trucks you're going to operate with are really important in the time of year. If you're logging in the winter when conditions are a lot slippery, traction is an issue, you're going to have a hard time making the top end of what a truck can reasonably climb. And same things in the interior on clay soils or organic soils or winter road kind of built roads there. A truck comes in from town empty, and it's very light, and you can climb a very steep grade. So the road going into the cut block we're less concerned about. The road coming out from the block to town is the road we're concerned about controlling the slope and not exceeding a certain range for your site.
So an empty truck can go up a much steeper slope than a loaded truck. So as you're figuring out the cut block, you need to know once the truck is loaded that it isn't going to be going up a steep grade, whereas if getting into the cut block it's a bit steeper coming up, that's okay.
Yeah, so we need to know if we can build a road to the location we want to harvest at. So this is one of the first things we figure out, and what it's going to cost to get us there. If we can maintain we can climb in at a certain grade, and then we can switch back and work our way back and forth up a hill to get to elevation, so long as we have the room and the turning radiuses to be able to accomplish that. We can't just draw a straight line from here to there and get there all the time.
So I assume part of that, in addition to the truck, I'm sure that, as you were saying, with the switchback, you wouldn't want a straight road at a certain grade just for erosion purposes, especially being on the coast here with the amount of rain we get. So you take that into account too as you're designing the roads? Yeah,
so like in this situation here where we're traversing and coming through these two blocks, we are essentially building a dam, and we got water that's at the high point wanting to go to the low point, and we're blocking it. So we have to on the upward side, which we call our cut side, we have to build a ditch, and so that water is coming down either from over the ground into the ditch line, and then we're controlling the water in our ditch to a point where it can access passage through the road. And we build those into the road at specific intervals and at specific sizes for the amount of flow we can measure and anticipate getting across the site.
I don't know if students can see it, but between us and the camera, there's a pretty sizable ditch here on this side of the road. It's maybe a meter deep or so. So the idea is that as the water flows down that hill, it's not going to go over the road. It's going to encounter the side of the road, and then you have culverts going under the road to go to the other side.
And culverts are just big pipes, and the length of pipe can vary, and the diameter of pipe can vary. The material of the pipe can vary. But we put those, if we have a natural stream or something coming down that doesn't have fish in it, we will put a culvert right there specifically so that stream can continue on the path that it always did. If it's just ground flow that's coming and collecting in the ditch, then we periodically put in one of these pipes to get water over onto the other side.
So in this case, there's no streams in this section behind the camera. We're just looking at water that's going to be flowing over the surface and collecting down here. So it doesn't matter so much where it crosses the road. You're just looking for spots where it's perhaps going to be the most convenient or cause the least erosion coming out the other side.
Yes.
And on this particular road, about how often did you put in? About how spaced apart are the culverts and how big are they, if you remember?
These are all, we measure in millimeters, so these ones vary between 300 millimeters and 450 millimeters, and they are spaced about every 50 meters.
And I would imagine it's probably, from an erosion perspective, it's probably better to have them more frequent and smaller than having fewer of them that are bigger, because when that water goes out the other side, I suppose it's a risk of erosion. What you said that you call this the cut side of the road?
This is our cut side. So if you were to look at the side profile of the road and the hill slope, we do half bench. So we cut in half into the mountain, and then we take that fill that we're taking out of the mountain and we put it on the lower side. So we call that lower side our fill side. So we're cutting in on the high side, filling on the lower side, and that's how we end up with a step notch in the side of the mountain. And that cut side is what's getting our ditch line, and the fill side is what the culvert is passing out onto.
I would imagine that the erosion risk then is probably going to be on the fill side, because if you have the culvert at ditch level on this side, it's going to be kind of high on the fill side. So what do you do on that side to try to prevent erosion?
Well, putting them in more frequently so that you have less volume going through each pipe is a big help. Sloping your pipe so that it's not perched, so it's not hanging out 10 feet and then just letting water hammer down. So
you want it to kind of immediately go onto the surface once it comes out the other side so that it can spread out and flow down rather than kind of pouring down like a fountain?
Yeah. And then we can use rock and aggregate material to build up the outflow of that culvert to help slow down that water. The other thing too is we try to slow the water down before coming into the pipe, which we build what's called a sump. So it's just a big depression around the inflow part of the pipe. And so the water coming through the ground that may pick up speed in the ditch now slows down in the pond fills, and then it flows into the culvert. And if you have the culvert sized right and in enough, close enough together, then hopefully you're not getting too much flow out the other side.
So one of the strategies, in addition to where the water is coming out, is just trying to slow the water as much as possible.
Slow it down,
okay.
Yeah. Anytime you put a culvert in, you're accelerating water. You're changing the hydrological dynamics of it flowing through the road, so it is a very important consideration. So we want to protect our road and we want to protect the environment, and the main thing we're protecting it from is sediment. We don't want sediment flowing down over the cut block into the ditch and filling our ditch. We don't want the ditch being filled or inadequate sized so that water is coming onto the road and then flowing down with the road, because it will mine our road away, it'll take all the fines away. And these fines get transported in the water system.
When you say the fines, you mean the very fine textured particles?
Yeah, the stuff that's equivalent to the size of sand or silty-like particles, some very fine textured materials and organics that can become suspended in the water itself and transported away. It's the matrix of all these sizes of materials right up to 6 inches and larger interlocking together, which is building your road base and cap of the road. So if you start losing some of these smaller sized components in that matrix, your road becomes unstable, it becomes undrivable, and you're polluting as well. And so we talked about fish in streams, and that's an important consideration when we're traveling, building road through areas with streams, that even if they don't have fish in the streams you're crossing, they may have fish in it downstream somewhere else. Or it might be a community watershed where somebody in downstream on the system is extracting water for their own drinking needs. And so you have to maintain all their rights and their protection of their right to water.
When you build the road, do you have different sized pieces, like different sized fill and different layers in the road?
Yes. Yeah. So our bigger, larger, coarse stuff is at the bottom. Sometimes we'll mix actually like the slash pile material and debris from building the right-of-way through and all the limbs and stuff, and we'll build a mat out of that first in the softer soils to act as a kind of a engineered mat to kind of interlock and help everything from squishing out and being able to build that foundation up. And then as we build, we're building up to a surface where we're getting more, we're building finer materials. And there's quite an art to it, and it takes some very good operators with lots of years of experience to be able to extract that material from a quarry, bring it here and rake it out, and kind of even sort it with this, with the teeth of the bucket on the machine that's building the road. And they're constantly sorting, and they're doing all kinds of things that don't always make sense to us. But in the end, they're pulling it all together, and you get a nice finished product like this.
So if you're in an area that's relatively flat and you're not trying to even things out, what's kind of the minimum thickness of rock and sand that you would use to build a road?
Yeah, so if you're on really good ground, you may not even add any material.
Okay.
Once you pioneer in, you might encounter some really good road building material right in place, some shale or some cobble, some nice fill in that road after you take the organics and after you've filled the right of way. So it can be anywhere from nothing all the way up to 3 feet or more, depending on what you need to cross.
Thank you.